This is part 2 of solving quadratic equations using square roots. We are on example 4, modeling real life. A touch tank in the shape of a rectangular prism has a height of 3 feet. Its length is 3 times its width. The volume of the tank is 270 cubic feet. Find the length and width of the tank. All right, so we have a rectangular prism here. So let's label. First it says a height of 3 feet. So we know the height is 3 feet, so that's this distance here. And it says its length is 3 times its width. So its length is 3 times its width. Well, we don't know the width, so we're going to call it W. And this will be 3 times W. All right, so let's find the length and width of the tank. All right, so it also gives us the volume. So we know that the volume of a rectangular prism is length times width times height. So let's fill in what we know. So we're given volume is 270. Length is 3W. Width is W. And our height is 3. All right, so we can simplify. 3 times 3 is 9. This is assumed to be a 1 in the middle when there's no number there. So this would just be a 1. So it's just 3 times 1 times 3, which is 9. And then W times W, same base, add exponents. Both of those have an exponent of 1. So that would be W squared. All right, now we can solve from here by dividing both sides by 9. We know that 9 goes into 27 3 times. Bring down the 0. I forgot my squared term, so that is W squared there. All right, and I'm going to take the square root of both sides. So W equals, remember this 30 is positive, which means I'm going to have 2 real solutions. I'm going to have plus or minus the square root of 30. All right, so I can approximate that using my calculator. So let's say the square root of 30 is about 5.5, and that makes sense because the square root of 25 is 5 and the square root of 36 is 6. So the square root of 30 is in between both of those, so it's going to be about 5.5. So we're going to have W is about 5.5, and this would be in feet. So about 5.5 feet. That would be your width. All right. And then if the width is 3 times that, we can say the length is going to be about 3 times the square root of 30. So 3 times the square root of 30, and that's going to be in feet as well. Let's see what that comes out to be. So we're going to have 3 and then times the square root of 30. And it's better to put the square root of 30 than the 5.5 because we've already rounded this number, and then it would be rounded again. So it would be further off than the actual number. So it's better if you put 3 times the square root of 30. And that's going to be about 16.4. And again, that's going to be in feet. And you can check your answer by saying, does 3 times 5.5 times 16.4, is that about 270? And the reason I said about, because we rounded these two, it may be slightly off, but it should be very, very, very close if we got the right answer. So let's do 3 times 5.5 times, what did I say, 16.4. And that is very close to 270. Again, it's off a little bit, but it's because the 5.5 and the 16.4 were both rounded. So we can conclude that these are valid measurements. All right, and you can see here that I only used the positive measurements. Why did I only use the positive measurements? Because we're looking at a real life situation. So we're looking at a tank, and the measurements, the length, the width, and the height, they can't be negative. So even though this said plus or minus the square root of 30, I only evaluated the positives, and that comes into this math practice here. You have to be able to interpret the results. And it says, why should you only have positive square roots in this situation? And again, that's because you have to have a positive distance, a positive length for each side of that tank. All right, last example, rewriting and evaluating a formula. Example 5. The area A of an equilateral triangle with side length S is given by the formula A equals the square root of 3 over 4 times S squared. Solve the formula for S, then approximate the side length of the traffic sign that has an area of 390 square inches. All right, so the first thing we need to do is solve for S. Solve for S. All right, so we're going to start. All right, start by writing the problem down. Let me see if I can write that A better. All right, the first thing I need to do is get rid of this right here, okay, because we're trying to solve for S. So this is the same as 1/4 times the square root of 3. So if I multiply both sides by 4, that gets rid of this 4 here, because that's like 4 over 1. So this is on the bottom. This right here is on the bottom. This is on the top. It cancels out. The 1's cancel. It leaves 4A equals the square root of 3 times S squared. All right, now we're still trying to get rid of this square root of 3, so let's divide both sides. Anything divided by itself is 1, so that goes away. And then I have 4A over the square root of 3. So it's kind of nasty looking. We don't really like to have square roots in the denominator, but right now we're just solving. All right, so when we have S squared, that means we have to take the square root of both sides. That means we have to take the square root of that whole expression on the left side. Even though the denominator is already under a square root, we have to do that as well. All right, now we can assume that this is only going to be positive, so we're going to have square root of 4A over the square root of 3, and that's going to equal S. And the reason I'm not putting plus or minus S, again, we're looking for the area of this sign, which means it's a positive number. You can't have a negative area. That wouldn't make any sense at all. So then it says, approximate the side length of the traffic sign that has an area of 390 square inches. So we're going to take the 390 and we're going to plug that in for A, area. So it's going to go right underneath the radical sign here. So we're going to have square root 4. I'm going to have times 390 over the square root of 3. All right, we're going to use our calculator to kind of figure this out. So we're going to say, what is 4 times 390? And that gives us 1560. And that's over the square root of 3. All right, and then after that, let's see if we can use our calculator just to plug it in and see what kind of answer it gives us. All right, so let's move this over a bit. So we're going to have the square root of 1560. And then we're going to leave this underneath the radical and do divide. And we're going to do the square root again of 3. Now you can see how this is still under the radical. We want that whole thing to be under the radical sign. So now we can hit enter and come outside and see what the side length is. So you can see that the side length of the traffic sign is about 30 inches. And we know it's in inches because it already says S is given by the formula. The traffic sign has an area of 390 square inches. So it gave us that in the beginning. So the side length of the sign is about 30 square inches. So if I do 30 and put 30 here and 30 here, remember what the formula for area of a triangle is. See if you can get 390 by checking that.